Open Source Technology Center in Espoo, Finland. And I've been working with the Zephyr open source project, the RTOS project now for the past couple of years. And in this first presentation, I'd like to mention, by the way, that we have some Zephyr stickers here. Just, I think, 4 or 5 of them for the best questions. So if you want stickers, you can come and claim yours. Yeah, if you're among the first ones to ask questions, let's see. Okay, so I'll be talking about Bluetooth mesh here in the first talk, and most of the presentation will be about the specification itself, the technology itself, and then I'll go a little bit into the details of what the implementation status is for Zephyr, and actually I will also cover a little bit on what we've been doing on Linux to support Bluetooth mesh. So the mesh specification, it was released this year in July, and there's been a couple of proprietary kind of mesh networking solutions built on Bluetooth, but now they finally managed to get everybody together and create a proper standard out of this. And as the name implies, it extends Bluetooth from your typical peer-to-peer connectivity to a many-to-many topology. And it builds on top of Bluetooth LE, and it doesn't actually require anything newer than a Bluetooth 4.0 capable controller. Bluetooth is at 5.0 now, this latest specification, but you can actually upgrade devices with 4.0 hardware to do Bluetooth mesh. And it's connectionless. It's the first version, at least, of the mesh specification doesn't do routing. Rather, you just broadcast packets out to have a time-to-live value and eventually find a destination or just die out in the mesh. And the bandwidth that you get with mesh, it's not anywhere close to what you would get over a typical Bluetooth connection, where you can get 1 or 2 megabits per second. With mesh, it's much less than that. So the most practical use case for it is basic signaling, small packets. If you want to send more data, you can do it, but then your use case needs to be able to accept the longer time it takes to get the data through. Same thing with latency, that if you have many hops that the data goes through, you're not going to get super low latency with Bluetooth mesh. It has an inherent concept of message publication and subscription. So when you configure the nodes of a mesh network, you configure some nodes to subscribe to certain addresses and others to publish to other addresses, and that's how they kind of talk to each other. So they don't have built-in knowledge of who they need to send messages to. Rather, you go ahead and configure each node. And security is not optional in mesh. It's built in. It's on several different layers. And the folks behind the specification have really tried to make sure that it's secure from the ground up. About the mesh node lifecycle, at the center, or kind of at the root of mesh network, is a so-called provisioner that takes care of provisioning devices and configuring devices. And when you buy a new device with Bluetooth mesh, it starts off as a so-called unprovisioned node, and you then need the provisioner to go ahead and do the provisioning procedure to give it the initial network key and initial address for the node. The provisioning protocol that mesh uses the same elliptic curve Diffie-Hellman cryptography that Bluetooth pairing uses. So they borrowed the mechanism and done it on mesh as well. The provisioning itself only gives the initial network key, peer-to-peer key between the provisioner and the node called the device key, and the address of the node, but it's not yet usable at that point. Once you provision it, you need to do a so-called configuration process where you give it additional keys. Could be network keys, or they could be so-called application keys. You configure the publication and the subscription and that kind of stuff. And once you've done all that, then it's a fully functional mesh node and can participate in the mesh network as it should. Then it might happen that you at some point sell your device or you lose it or something like that, and you want to make sure that it doesn't compromise the mesh network that you have in your home, for example. And there's a process called blacklisting with which you distribute new network keys to the nodes of your network, and you selectively leave out the nodes that you don't want to give the key to. So that would be the node that you don't have in your possession anymore. And then a node which has been blacklisted, if you want to take it back into use, you need to perform a so-called reset procedure on it, after which it returns back to the unprovisioned state and can be provisioned again from there. A little bit about the composition of how Bluetooth mesh nodes are logically constructed. The nodes are called, the physical devices that you have are called nodes, but they can contain one or more so-called elements inside. And mesh element is the basic addressable entity that you have in a mesh network. So that's the one that has a mesh network address that you can send messages to. Each element in turn can have multiple so-called models. And what the model is basically a definition of states and messages which can influence those states. And you have generally two categories of models. You have those that mostly initiate sending messages. They're called client models, and then those that receive messages, and then which are often requests and then respond to them, which are called then server models. A little bit about the layers. So it's not a particularly simple specification as such. If you start from the let's see if this works, from the bottom there, you've got the two transport bearers that mesh supports. The kind of native mesh transport bearer is the advertising bearer. But alongside of that, there's an optional GATT bearer. GATT is the protocol that's used for connection-oriented Bluetooth LE connections that all existing Bluetooth devices use. So in many cases, for example, phones and PCs, you will have to update the operating system to get the right kind of advertising bearer access to be able to do native mesh. But if you want to update or create an application, for example, for your Android phone, right now with the current Bluetooth APIs that there are, you will need to use the GATT bearer to do that. And the way it works essentially is that the device which can only use the GATT bearer, it requires a second device acting as a so-called GATT proxy that has the connection from the GATT client to the GATT proxy, and then the GATT proxy talks to the actual mesh network, and that way you're able to get messages through from a device which cannot talk the native advertising bearer. On top of that, you have the network layer. It includes network layer encryption. This has the addressings where you have source and the destination address. The source address is always the address of some element that's sending the message. Destination can be a group address or then another, it's called a unicast address of another element. You've got transport layers on top of that, where you have support for segmentation and reassembly. The actual packet payloads that you have in mesh packets, they are quite small. We're talking about up to, I think, 15 bytes at most. So if you have a message that's bigger than that, you need to go ahead and segment it, and then it can be reassembled on the receiving side. And then there are some kind of generic features like heartbeat and friendship. I'll go a little bit into friendship later in the slides. And you've also got a second layer, so-called application layer encryption that the transport layer is responsible of doing. On top of that, you have the access layer, which does the multiplexing between the different models to get the message going to the right model that the node is implementing. And then on top of that, you have the actual models that are implementing the handlers for the messages and so on. Quick overview of how relaying works in mesh. So every packet has a time to live value. It's a 7-bit value, so it gives you 127 hops that you can have at most. A node that's relaying doesn't need to have the application key to decrypt the application payload. It only needs to have the network key. And what it does is it decrypts the network payload. It gets access to the time to live value like that. It decrements it, and if it's still high enough, it re-encrypts it and basically broadcasts the packet back out to the network. It's worth noting that not every node in a mesh network will be a relay. In fact, it's highly suboptimal if you have every node being a network. They have done some simulations on what makes sense, like how many nodes you should have as relays, and it boils down to something less than 10% of the nodes will give you fairly optimal relaying functionality in the network. One of the challenges with doing a Bluetooth mesh node is that every node needs to be listening so scanning on the advertising bearer all the time to be able to see if there are any packets for it. And this can consume quite a lot of power. So if you have a device that has just a coin cell battery or otherwise limited power supply, it might run out of that quite quickly. So Bluetooth Mesh comes with a solution for this, which is called Friendship. And the general idea is that you will have some nodes in the network which have a more stable power supply. And you can make those nodes be so-called friend nodes. And the general idea is that the friend node will cache messages for so-called low-power nodes. And the low-power nodes can then wake up only once a day or once every 2 days and ask the friend node that does it have any messages destined to the low-power node. I could give a practical example. One of the first actual real mesh products that you can already go and buy is smart lights and switches. And in that kind of setup where you have switches talking to the lights will need to be listening for messages all the time because they need to be switched on as soon as there's a message to say that, you know, switch on or switch off. They also have a stable power supply. The switches, on the other hand, most of the time, they will only be sending out data. They don't really need to be constantly listening for any messages for them, except potentially if you want to do a firmware upgrade of the light switch or something like that. So this is a perfect scenario for Friendship, where you make the lights be the friends and the light switches be the low power nodes. And that way you can have just a small battery in the light switch and still have it operate in the mesh network for a long amount of time. So that's so much about the actual specification. Let's look a little bit about what we've been doing implementing mesh support for the two open source projects I'm involved with, so Zephyr and Linux. For Zephyr, we've been working on the mesh implementation long before actually the specification went public, and we pushed it upstream as soon as the specification itself went public. It's available from the current stable Zephyr release, which is 1.9, and implements all of the mandatory features. We've been testing it against various other implementations at interop events, and it should be working fairly well. It was also ported to another RTOS, Minute, and they've actually been doing on that side as well quite a lot of testing, and we've received fixes back from them, so it's further matured thanks to them as well. And you can run it on pretty much any Bluetooth capable board that Zephyr supports. If people are interested, I have some BBC microbit boards with me, where I have Zephyr Mesh application. They are also nice to show that you can actually get it to a very small memory footprint, because these boards only have 16 kilobytes of memory, and you can still do the full Bluetooth mesh with them. Then about Linux. So it's not quite to the same level of support as Zephyr has at the moment, but we're working on it. The last BlueZ release has a tool which you can actually use to talk to Zephyr devices called Mesh Control. The limitation of Mesh Control is that it does only the GUT bearer that I mentioned at the beginning of the presentation. So you actually need to configure, if you're talking to Zephyr, for example, with this one, you need to make sure you have the GUT proxy support enabled in Zephyr. It also does the provisioning protocol over GUT if you have a device which needs it. And we've started work to get the full native advertising bearer working in Linux as well. And I think we're going to have the first batches for that sent upstream by the end of this year. But it's something that is not yet quite there. What it will consist of is a new user-space mesh daemon, which will then take care of talking to the kernel, which will be taking care of the advertising bearer semantics. It will be important to make sure that the mesh usage of the advertising bearer doesn't conflict with traditional Bluetooth LE usages of the advertising bearer. So the kernel will be responsible for managing that. And pretty much everything else will then be in user space. A little bit about what we're working on in the short to medium term. In Zephyr, we have full access to the Bluetooth controller, and we can actually do some optimizations which you can't do with standard Bluetooth hardware. In particular, the friendship feature that I mentioned earlier, it has the possibility of configuring the relationship with really, really tight timing constraints, like just a few milliseconds that the low power node needs to listen for the packets from the friend node. And with standard HCI, which is the interface between the Bluetooth host and the Bluetooth controller, you cannot actually get the strictest possible timings with that. But we have defined some extensions for the Zephyr HCI with which you can get all of the range of possible timings that the mesh specification allows. There are some missing features, even though the mandatory ones are implemented in Zephyr. Friend support is one of them. So as of right now, the Zephyr upstream tree, if you build a mesh node out of it, it cannot yet act as a mesh, as a friend node. But this one should be there, I think, within a week or so. I've been actually heavily working on this while I've been here at the conference as well. And there's a whole separate model specification in addition to the mesh profile specification, which has various kinds of general and some more dedicated models that you can implement. And we'll be looking at what of those make sense to include as the core part of the OS and what we should leave to the application to do. And we're also working on coming up with different ways to demonstrate or kind of visualize how to use the mesh network and how it works. And actually, that's all I had. So we can move on to the questions.
Thank you for the talk. I have two small questions. First of all, I didn't catch, how do sender can be sure that receiver got the message?
It depends. So mesh has both unacknowledged and acknowledged messages on the transport layer. All segmented messages by default receive a segment acknowledgement. So the receiver will say that I have received these segments of your message. And unsegmented message doesn't have any acknowledgement on the transport layer. So if you want to use that and you need an acknowledgement, you have two options. You can either send the single segment as a one segment segmented message so that the receiver is forced to acknowledge it, or you can do it on a higher level so that there's on a mesh model level, there's a response message saying that it received it. That's the other option.
And the second question would be, what are the power requirements for the low power nodes? I mean, in the means, what do you get from standard, I don't know, shared battery, for example?
I would imagine that if you are able to configure it to the minimum possible timings that you can get in the friendship, you would get years, many years of battery life. Because what you can do, I think if you push it to the extreme, a low power node needs to wake up for, I think, 30 milliseconds every 48 hours. That's very little.
Yeah.
Thank you.
Yeah, no problem.
Thank you. Next question.
Thank you for your talk. I have a practical question. How many Bluetooth devices could I join to one mesh network? What's the limits?
Okay, so the mesh network address is 16 bits. It has the two first bits reserved for the address type. Is the unicast address, is it the group address or something like that? So you have 14 bits left for unicast addresses. So 2 to the power of 14 then is the kind of theoretical maximum number.
Okay, it means I can cover by mesh network very big space, right?
Yes, that's a lot of devices.
And second question, probably if I try to build some smart infrastructure like smart house or smart something, so what do you think, what's the best way to join the mesh network, mesh sensor network with like some data distribution service like DDS system or something? Because I guess it's different protocols.
Yeah, you need to have a so-called gateway device that does the translation from one to the other. I'm not sure if it was released yet, but there's been work on a white paper to describe mapping to some common networking protocols. But for many, you will just need to have a custom solution that translates the two kinds of technologies. Yeah.
Okay, the next question, and we have about 4 minutes before next talk.
Can you tell us about advantages and disadvantages compared to Z-Wave network?
Compared to what?
Z-Wave.
I am not familiar with that. One of the advantages is that I bet you cannot do that with your phone. I mean,
Z-Wave, yes, we can.
you can.
We can.
You can't. Yeah. That's the only thing I can think of. I mean, if you compare it to 802.15.4 or something like that, Bluetooth is much more proliferated you find it in PCs, you find it in phones, in many devices. So you can just, with a operating system upgrade, you can get mesh support there. You don't need new hardware necessarily for that. So I would say that's perhaps the biggest advantage.
Mm-hmm. Because Z-Wave supports up to 256 nodes in network, 256.
Okay, well then you can have more.
But it doesn't work very well.
Okay.
We tried to build a smart office with Z-Wave. And second question, did you already have or so end devices which supports this new technology?
Yes, I mean the Zephyr RTOS that I work with. I mean we've been putting this on. Do you mean like a device?
Temperature sensors, actuators.
Do you mean actual devices you can buy on the market, or something we've been playing around with ourselves? So there's at least one company called Silver. It's a Polish company that announced a whole range of smart lighting products the same day that the mesh specification went public. So at least from them you can get some products. I don't know what other companies have already launched commercial ones, but at least if you have any board that can run Linux or Zephyr, you can play around with those as well, since the implementation is available in the open.
Okay, any more questions?
There's one at the
I
back
think
there.
this is the last one.
Sorry, kind of for this Bluetooth mesh network, is there maybe any time synchronization protocol for synchronization time between?
So there is, in the mesh model specification, there is a time model that you're supposed to be able to do something like that. I haven't actually looked at the details, but there's something there for that.
Mm-hmm. Okay, thank you.
Thank you, and because I dealt with Bluetooth technology for about 4 years before joining Dell EMC and have not followed the protocol for last 5 years. It's very interesting for me personally that it's now it is a standard for mesh that takes years to be standardized. Thank you.
Yep.